So, I would like to take an example that is of ball. This ball, as you can see there. This is a cricket ball, and I will take it. I'm taking it in my hand. As no force is applied on it, it is in rest. Now when I'll apply a force or like this, so at that time, suddenly when I try to change it into rest to motion, suddenly what will happen, this ball I have, it will try to stay in rest. So what a particular inertia tells to us that an object, if it is in rest, tries to tend to stay in rest. If it is in motion, it will try to stay in motion. This property of object is known as nothing but inertia. And if this ball is moving, with the help of this ball, we can also understand the second law of motion, and I think third law of motion. We can also understand third law of motion. So what our first law of motion tells to us? If I talk about English definition, that is nothing but, it's just like, it's not too much complicated to understand. It is a little very simple. But when you will understand the real life application of the first law, you can easily understand, you can easily derive the formulas from the definition. So that our first law of motion tells to us that an object remains in rest if it is in rest, or remains in motion if it is in motion, unless an unbalanced force is not applied on it. Now, if I take that ball again, this ball, see, if it is moving, if I want to make it in rest, so I'll have to exert an unbalanced force on it. Yeah, this is too much important, and this is what that our first law of motion tells to us. See, it's just like, I can't, that is, I don't know what we say that thing. But I think you can understand what is in our first law of motion. And if I talk about a particular applications of a real life of the first law, that can be of bus, a transport bus. How? Because a particular, when I'm standing, like, you must be aware of about some of the handles are situated at the top of the particular roof of the bus, and the people take that particular handle, and sometimes the bus is with a full acceleration, with a high acceleration, and suddenly driver see that is red signal. What? Red signal. So now he'll have to wait for a second. So he press brake at that time. So when he pressed that brake, what happens? First, my bus was in a particular in motion, but when my particular what we say that thing, yeah, my unbalanced force applied. When my unbalanced force applied on it, what happened? Yeah, you were right. It stopped. My feet were also at the contact of that bus. Bus was in motion. My particular in my foots were also in motion. Suddenly, my upper body. Please remember that thing. My upper body was not in motion. It was at rest. So my upper body was at rest. So when it got break, so it have to go. It will try to remain in motion. So to make it at rest, my body goes like this. You can understand what I'm trying to say. Yeah, that is what I was trying to say. That one application of first law of motion, and there is another thing, and that thing has nothing but forces directly. There is a formula that is force is directly proportional to my mass. Force is directly proportional to my mass. Is it right or is it wrong? Yeah, it is right. But how? How it is right? Let's suppose I have a particular a coin of 5 rupees and a card. You must be aware of cardboard and a piece of cardboard. And from that piece, what's happening to the camera? Yeah, from that piece, I took. I didn't did the particular activity, but I saw it in my textbook. So what they did is they took a tumbler, a cart, a small piece of cardboard, and a coin, and they very fastly they kick like this. With the fingers, they do like this. My cardboard gets struck it, but my coin. What my coin got to my particular in the tumbler. It fell to the tumbler. Why? Because when my object was at rest, my card was at rest, my coin was at rest. So my coin tried to stay at rest, and he got it. Why? It didn't went with the particular card. Why? Because it tried to stay in. It tried to stay in rest, but it can't. So it falls to tumbler. Yeah, absolutely truth. Yeah, very absolutely. And from this we get a particular proportionality of force. That force is directly proportional to my mass. Is it right? Yeah, absolutely. And my force is also directly in this. It is only that force is directly proportional to my mass. if I take example of truck, a truck is at rest. You cannot make with a little unbalanced force to move it. You cannot. If I take about example of this particular ball, yeah, I can easily do. I am using my 5 Newton force at this ball, and that exactly Newton force on my truck. But my truck has more mass. More mass is equal to more inertia. Please remember this thing. My ball has lesser inertia than my truck. That's why it is not going. It is not moving. It's moving. My ball is moving, but my truck is not moving. This is a particular proportionality that you must remember. Oh my God! It's really. Oh, let's move on to momentum. What is momentum? If I talk about momentum, what is momentum? We know that momentum. Here, first thing that I would like to say that momentum is equal to mv. Means mass multiplied by velocity. Now, understand my thing. Momentum is what? You know that let's suppose there are two person, me and a person that is more. It has more mass than me. And I have lesser mass than him. We are standing. There is a door in front of me and in front of that person, and we want to break that door. First, he ran, and he broke the door. Exactly of same size and of same weight door came again to me, and I also kicked that particular door with the same length. I mean, if this is my door and this is me, first that person kicked and he broke out, and when I kicked it, I got hurt. But that door was exactly like that. Why? Because force is directly proportional to my mass. We have already studied in my inertia. What I said? My force. If I want more force, so there must be more mass. This is first proportionality, that force is directly proportional to my mass. That person has more mass than me. That's why he exerted more force than me and he broke out. Now, I thought that what can I do to do this thing? Again, what I did, my mass was remain same. But what I did, I came from 25 meters or more than 25 meters far from that door and run, and then broke out it. Then I kicked and it broke out. I said, how? How this is happening? Because my force is directly proportional to velocity. Yeah. My force directly proportional to my velocity. More velocity, more force. When I came from 25 meters far from my door, what happened? Nothing happened. But my mass remained same. My mass remained same, but my particular velocity increased. And there are two proportionality that we got for momentum. I didn't told you not anything about the momentum. I'm just saying we got two proportionality from this activity. First was we also obtained that from a particular first law, but I'm saying it again. I'm going to tell you again. That is, my force is directly proportional to my mass. Force is directly proportional to velocity. two things. Now why I say that force is directly proportional to mass, force is directly proportional to velocity? Why? So there is one term that was made by Isaac Newton, and that one term is momentum. Symbol is P. And what this tell? That momentum P or my P force is equal to M multiplied by V. The product of mass and my velocity is equal to P. That is momentum. So the symbol is not big P. It is small p. Okay. And what was that? Nothing but momentum. Now there is change in momentum. Momentum is changing. Now how would you get that momentum is changing? How? Very easy. What you'll do is my first momentum minus second momentum is equal to change in momentum. Exactly. Nothing but. You can understand it. I mean, my first momentum was this, my second momentum is this, and when I'll minus it, I'll get it. Exactly. From this change in momentum, we have second law of motion. What? Second law of motion. Wait a second, I'll get that. Yeah, I am here with my cricket ball. Anji. What a cricket ball. What is this? Yeah, I'll give you two examples. Observe me carefully. Now, I'll put you a question, but not now. First, I'll tell you the theory. What a second law tells. A second law says to us that the acceleration acquired by an object is directly proportional to my what? To my what? Yeah, you're right. That is force. It is directly proportional to my force. When this acceleration is my force. Yeah. This is told by second law of motion. But cannot understand? You cannot understand? Let's take, there is a concrete floor and a glass tumbler. There's a concrete floor and a glass tumbler. And the acceleration of that glass tumbler, one inch above the concrete floor, was 100 kilogram meter second. Kilogram meter second is the SI unit of momentum. As you can also acquire this particular thing by the formula. What is formula? M multiplied by V, mass multiplied by velocity. What is the formula? Velocity. M multiplied meter per second. And what is the particular SI unit of mass? Kilogram meter per second. You got it. But now my thing is that what I was trying to say that yeah, that concrete floor, the momentum that the particular not acceleration, it was momentum. It have, or we can say velocity, in simple word, velocity was 100 meter per second, and at ground, at when it strike to that floor, it was 0 suddenly. Change in momentum 100. Let's suppose momentum 100 kilogram meter per second. A great change. When there is a great change, it broke down. And if I talk about my particular bed sheet or sand, it will not broke down, as my that particular my second, my P2 momentum in final momentum was not exactly at 0. It went to 0, but not at the time. So what this tells us? What this tells us? It tells us the velocity of the object changed to 0 suddenly in the first case, but in second not. Yeah, it's right very much. So it tells us that our force is indirectly proportional to my time. Time taken to make the final velocity to become 0. If the time is more, so the force exerted is less. If my time is less, my force will be more. Now, if I talk about my cricket example, like that, here, see. First, see my catch. Oh, wait a second, I'll do it again. It's here in there. In my first catch, what I did like this again. What I did is, when my ball goes, I take it. Force was too much, and it can hurt also me. But when I do like this, when I catch, I do like this. When I did like this, why? Because at that time my momentum was much, my velocity was much higher. It becomes at the time 0. But if I talk about like this, or if I talk about wait a second, my momentum was not exactly at 0. It came, then 0. So the time taken was too much, and my force exerted was less. This is what a second law tells. Second law's formula is force is equal to kma. I'll tell you how it came from. First, force is indirectly proportional to 1 or time. Correct. And another was I think it was in relation with the mass and I think acceleration. Not acceleration, velocity. Yes, my momentum. Change in momentum. My change in momentum F is equal to mv2 minus mv1 mv1 minus mv2 divided by time. Oh, it's not just like this. Now my time, when I derived this both the proportionality, and I got a formula. That is, F is directly proportional to my particular time will be at the denominator, and on top I have f of v1 minus f of v2. Here I can take m as common. Yes, m v square minus v1 v square v2 minus my final velocity minus my initial velocity divided by time. The final velocity divided by initial velocity divided by time. This is the formula of, yeah, you are right, acceleration. M is directly proportional to my F is my force is directly proportional to my ma, acceleration. Now to make it formula, F is equal to k ma. What is now k here? What is this k? K is the coefficient, that directly proportional coefficient, proportionality coefficient, and the value of the k is 1 always. What is it? So this is what you need to know. Too much easy. Second law. If I move to third law, third law of motion, what third law of motion tells to us? What? It tells that if the first object exerts force to second object, so second object will also exert force to first object. Let's suppose like this. See. What's happening? I am doing like this, and ball is coming to me. Yeah. Ball is coming to me. Why? Because when I exerted force to ball, it moved to down. Ball and it hit strike to surface. That surface exerted another force to ball. And I got that ball. But you know that this magnitude of both the force will be equal. It will be equal, but as it will be equal, but in opposite direction. If one is plus 10 Newton, it will be minus 10 Newton another. And this force will only exert in two different objects, not in one. If you want any application of force, application, I can give you application walking. When I walk, I make the ground to slip there, and ground say to me to walk here, like this. And swimming, when I do like this, water comes back, and it say to me to go up. Yeah, that is what third law of motion. So I hope, friend, you understand that today's topic is fully completed. And I'll meet you in my next video. Until then, stay connected with me. Thank you very much.